Hello. Only pointers, or what is in it? Vertex data and position. Vertex data and texture coordinates. Instance data and position. Push constant mx position. Push constant texture index. Well, yes, those two are there. What is there? What else is there? Texture top, alright. Texture bottom, that was the last one. It is NeoVim. Seems that every shader resource or shader variable is in there. And the first one that we find, the first of the push constants we find at least, is, well, that one. Which is logical because it is in this vector before the other push constant. This one is being used in program stopped, damn it. Keep typing that wrong. eVertex, still another thing wrong. It's broken. Anyway, eVertex, correct. Could have seen that here. Push constant is used in vertex shader. Push constant declaration context iterator. Shader input data TLSL ID full to push constant. Declaration context. Find prefix. Guess prefix is just push constant. Yep. and it should find, of course, that didn't work. So I think that the size of this thing should be 1. There's only one push constant, right? Bad array bounds. Excusez-moi. Yo, doesn't know what this is. Oh, it's interesting. No, it just, size should be 1. It should return the only iterator letters. Points to push constants. Well, that's the key. This is the push constant declaration context. So I could print I guess that's like that. Push constant declaration. What I meant. Okay, I guess this describes the push constants declaration, and it has a header, the way we are going to declare the push constant, which is having an not so human readable name. And currently we have 0 push constants. Map is empty. I guess. It cannot be end. It is not end. That's what I just did. It gets context. Now we call a GSSL ID full is used in shader stage, this shader input data, blah, blah, blah. And I guess that will be adding it. After that, we just return a pointer to the context. I'm going to do a step. That is push constant dot x position. Yep. Entering push constant declaration context, GLSL ID full is used in push constant x position, comma vertex. It should be inverted because the is used in vertex. Or maybe it's like this. The GLSL ID full, is this the first one, is used in vertex. Okay, I agree. Let's leave the order. Nobody knows what minimum offset and maximum offset is. Try and place. Shader stage. I guess we keep track of a minimum and a maximum per shader stage. And that's the vertex shader. We're filling it with the maximum value and then the minimum value, in respectively the minimum offset and the maximum offset. Yeah. Now the push constant offset is 0, I guess. 0. And it felt like running a random thread again while I'm printing something. What a nonsense. So now both minimum and maximum are 0. Oh, okay. So try and place. Yeah, it's try and place. Okay, so it just inserts it if it didn't exist yet. So the next time we'll get back to 0 for that shader stage, because then it already exists, and therefore it will not in place these constants here. What is this? So map of 2 elements, texture index and MX position. Yep. That is correct. Rather that one. Here's another one. This is the key, and that's what is stored in it. Same thing here. We run over all the push constants. Line 35. Get a pointer to the push constant. Okay, so we of all the existing push constants. We find the one that has the minimum offset and the one that has the maximum offset, but all the push constants in between must be added in the declaration, otherwise, well, something goes wrong. So all the push constants in this range are being added. Guess it just does this every time, again and again. So at this moment we just have one push constant, one that we just saw, which was I can scroll up where you actually see the value. That is used in I'm still looking. That one, right? Yeah, so we just saw push constant mx position in the shader code. And so as far as it knows, that's the only one, which it happens to be at offset 0 in the push constant struct. So we need to define or declare a struct called push constant with that element at offset 0. That's not the one. O is mx position in the with what? Fuck again. It's unbelievable. And I didn't even print a result. I'm going to try again to print it. Maybe now it works. Four. Okay. In fact, I can see everything, I guess, by printing this. Except printing it. And that says that this is texture index with an offset of 4. Okay. So that falls outside this range, because what he found, I think, had a minimum offset and a maximum offset of 0, right? And these are both 0. We are looking for the one with an offset of 0. So this is in reverse in that vector, I guess. So this is not true. And we go to, if it is equal, nope. What is that? Oh, yeah, okay. Well, neither is true, so we go to the next one, and that then is the right one. Print. Now we have the texture index, which is the one that we found. Ooh, offset 4. Okay, now I'm confused. The last one was the same one. I didn't execute this line yet. Next. Now it is X position. Okay, which has an offset of 0. Finally, we're getting somewhere. So this is the one that we found, right? Just to be 100% sure. Up, up. Shader variable is used in. I can just print shader variable here. And that is the X position. Yep. Push constant in range. Push back, push constant. X position, right? Yeah. Is it equal to the maximum offset? Yes, also. And the offset end becomes the push constant offset plus the push constant size. I guess. Do I dare to print it? Not really. Let me just print the whole thing again. Look for the size. Well, I guess the size is 4. Again, it's a bit unclear. Maybe this one. Yeah. There are no more. Can I print F offset? And it's 4. Yeah. Okay, so the size of push constants in range is currently 1. And there's nothing to sort. I go all the way. Stage flags. Insert. Yeah, okay. Elements clear. Was already clear. What is this? 58. This just generates the declaration. It's apparently one member. Float mx position. There's a comment after it. Okay, so that is what should go into the vertex shader, unless we find more, of course. And we will, we should. I think I'm just going to do next here. Preprocess. Yeah, we are still running over all the shader variables. So let's go to the next one. Texture index. No, I'm not sure, but I think that texture index is also found in the vertex shader. We're still in the vertex shader. So this is the source code. Can I just print the source code? That's not the whole source code. And I forgot how to print everything. It's not set element 0 or something like that. Nope. Need to print the long string. Print elements, set print elements 0. So not set element 0, but set print element 0. Layout. So vertex data. We'll only see this push constant. There is no other push constant. Yep. So this match string is not found in the source. And therefore we should go to 219 again. And then yeah, we'll might find other things, I'm not sure. Okay, that's it. Then now I do continue, it's going to stop at the breakpoint again, and then for the fragment shader. There's one thing I wanted to remember here, however. Declaration contexts is used in. I think that the declaration context here should contain. See, it has two elements. Nobody knows which is which. Can I just do this? No. And it's silently left TDB again. Again. What? No, that's weird. Second breakpoint also for the vertex shader. Getting sick of this debugger. So now we hit another breakpoint. This time we do hit a breakpoint for each fragment. Why am I hitting the breakpoint twice for the vertex shader? Hmm. Yeah, that was my breakpoint again. Yep, there's two of them that stop in for the vertex, and the bloody reason is, of course, that I have two pipelines, so that was confusing. I think I just should get rid of one pipeline. Run or not to run? That is the question. Not to run. I need to set a breakpoint again. Okay, let's I forgot again what it was. Of course, where was my last breakpoint? Is it somewhere here? It's not far up. There. What exactly is this doing? I guess I can just add my breakpoint here. I don't know what happens to a private photograph when you post it all over the internet, allowing everyone on YouTube to see it. Then it's not private anymore. It did break the hit point, breakpoint, so I now do continue. It stops in fragment. Much better. I want to see it from the top again though. A point that I do not understand is why this is not generating a declaration. Let's remember this pointer. This pointer. That's the pointer to the push constant declaration context. Okay, which ones do we have? I guess that the push constant declaration context is not a shared resource declaration context, and therefore we don't do anything here. But then where does it get generated? Suppose here. Yeah. Let's set a breakpoint here. Two, 5, 7. And it breaks at breakpoint 1 again. What a fragment shader. And then And then nothing. Hello? What a really great debugger is this. You type next and it hangs. I was stepping through 5. I just wanted to hang. It's not possible. Should just print something. Why is it waiting here? Oh, the CR mutex. So some other thread is also writing. Doesn't look like it. Which other thread has that? I'm in thread 5. Down. Mutex. The owner of the mutex is that, which is thread 3. To new, right? No, nobody understands why that was hanging. It's not hanging, is it? This thread is not hanging. Definitely should not be hanging. Disables async cancel. Has it unlocked itself? Right, now we're here, line 22. Get the push constant context iterator. Now prefix is still push constant, and now we should find it. And probably the same declaration context as we had before. I pasted it in the chat, and yes, that is the same. But it shouldn't be, because this is a different shader and we didn't generate it yet. So then what happens? See, there's already one declaration in it, namely for the MX position. It wouldn't be too bad if now it simply added the next one and then generated that. Something is going wrong. I'm not seeing what is going wrong yet. Frame. This context is fully used in. Okay, I'm gonna do step. Fragment shader and texture index is being used. Minimum offset. Minimum offset already exists and is 0. So that means that now this one should also already exist, I guess. Also be 0. So minimum offset is already 0. Maximum what? What? Just printed it. A minimum offset, standard map with one element. Oh, that's because it's a vertex. Okay, now I'm doing it for the fragment shader. Yeah, okay. Yeah, that's still the same thing. The thing has an offset of 4. And this is the one, but minimum offset is now 4 and maximum offset is 4. Okay, so we should find this one. Push back, push constant. Is it equal to the maximum offset? Yes. Plus size. The other push can't not fall in the range. And that was it. Sorted. Insert push constant range. Yeah. Ah. Aha. It erases the previous thing that we found. Okay. Yeah, now I'm going to think. there's two solutions, but I cannot explain it. I want to. I mean, you still have to decide which of the two solutions are the best. Okay, I got lost. Yeah, one solution is that I don't understand this, so I don't know. I mean, I could add it here. I have to understand why I did this. Why am I only interested in shader resources? Nah, I don't know. For no particular reason, I choose for option 2, which means that this must be made working. And declaration for stage. Push constant declaration. Shader resource declaration. Now, for example, if you look at this one, it keeps shader resource declaration. Shader resource declaration. It keeps something per stage, anyway. Vertex attribute declaration. It doesn't seem to do it. Does it look at shader stage at all? Am I crazy, or is this a add declaration for stage? That is a virtual function. Okay, the problem is that m_elements is not depending on the shadow stage. Let's just do the same thing as for the rest. Gonna go here. Yeah, how would the default constructor look like this? Passing a initializer list, just the first two, and then ignore the third one. I don't want to add a constructor here. Try that. Might not compile. Let me test it. I guess that compiles, because I did not complain about this. Yeah, I have to repeat it here. Maybe I should use a reference anyways, as in we do that. Another confusing thing is that I think that this should always be clear. Empty already. Which kind of means that this always would insert. And then why does this code exist? I think I just got confused. In other words, I don't expect this to ever not emplace anything. The whole thing should be, M6 data should just be empty when we call this. Or not. No, wait, we can be called multiple times, I think. For the same thing? I think. Use in, yeah, of course. We can be called multiple times. Yeah, of course. Okay. But we never do anything with M elements, or do we? Yes, we do, here. Why would I clear it? Okay, yeah. I'm clear. The clear, even the clear is good, but I need to. Let's get a reference to elements as well. So I want to have it now called members, by the way. Members. What? Array? Oh, right. Yeah. Hmm. minimum offset stage data. Okay, not getting that. Push constant declaration constant stage data has no memory name minimum offset and no memory name maximum offset. Struct standard pair. Oh, it's still a pair. Yeah, this is the iterator. Yeah, okay, getting it. First is the iterator. Does it expands to something that is the first is the key, right? So I need second. Second. Thirsty. I'm horribly thirsty. Stage data. State data. I'll be right back. I'm going to get me something to drink. Actually, I'm going to get myself just water, a glass. Excusez-moi. Yeah, this is so good. Yeah, it works again, I guess. Oh, it doesn't. What is the complaint? Overlapping offset. As I do not contain. So here it says vertex. No, that's it. Yeah. Not clear at all. How can they manage? How do they manage to make such unclear errors? Yeah, what I'm doing here is just saying everything. The whole push constant in both vertex and fragment. So all 8 bytes are to be available to both shader stages. And that's not what I'm telling the pipeline layout, apparently. I mean, I guess I'm not, because... this is the vertex shader, and it only declares size of 4. I mean, this is the only thing that I'm using. So why declare more? And then the fragment shader. Oh, the fragment shader doesn't have any declaration at all. What? No, this is code, sorry, preprocessed. Fragment shader. There's a push constant with just the M texture index. Because that's the only thing that I'm using here. Excusez-moi. Okay, so I'm having a range from 4 to 8 for the fragment and from 0 to 4 for the vertex. Apparently it has a problem with what I specified in the layout. Now I would like to know what that is. What did I specify? No, right. I guess this stage flag. So for the vertex only range 0 to 4, on the fragment only 4 to 4. And then how do you have to bind that? In 2 calls? It seems unlikely. You can use the validation or link, I guess, this one. Yeah. Looks like you have to do 2 calls. 2 calls to VK command push constants. Why? No, okay. Just like that. It's like this or the other way around. And that solved the validation errors. Right. Jennifer, yeah, that sounds good. Day and night. Just keep trying. I found myself that it is advantageous, I think, to have no deadlines. It's when you find when you feel under stress, you learn less. So you have, say, a problem, you can't fix it. Then make that your main project. It doesn't matter if that takes weeks or months. I mean, say you're trying to write a game and you get stuck on multiplying two matrices. Okay, then that's your problem. Dive into it, become the world expert on multiplying matrices. And your game, well, who cares? No deadline. If you always work like that, then you work most efficiently. I mean, I'm not saying that you're writing a game in a commercial way, but as a coder, you grow faster. If you just really learn non-stop, doesn't matter what. For example, when I had to do matrix multiplication for even this application, I was like, yeah, okay. And I spent a week or so investigating all the existing libraries, and I picked one. And then I had to learn how to use it. So it was another week or two at least. I mean, just to do anything with it. And if you do that in a rush and then don't use it for a while, then you forget everything again. Well, if you really make it a project and you do something with it, you write several things using the API of the library that you picked, then you know how to use the library. I always say the only thing you know is what you wrote. You know, you have to be able to look back at programs that you wrote. And if it's only in your head, you're gonna forget it. You need to have written code that you can. That's kind of your portfolio, say. And then I was showing code on Discord, and it popped up that I was using this library, and they said, "What? Why are you using eigen?" Which I picked for some reason. Said you have to use this or that library. That's specifically for game 3D games, written for. But I don't understand. I didn't understand. I still don't understand what I exactly meant. So I did not drop everything and started to learn the other library. I was like, yeah, okay, maybe I picked the wrong library, but I'll run into it by the time I get to it. So maybe I did everything for nothing. But if I had a good memory, then at least I could have said, well, but now I know how to use eigen, and I don't. But I do, because when I grab eigen, I get every code that I wrote with it. All kinds of examples. Not that much. Pretend there's a lot of examples, because I actually used it. I didn't actually use it. That's the whole point, of course. It's like 2 lines here that I actually wrote code. So yeah, now I do not know anything else than how to do these 2 lines. So maybe if they took me 2 weeks, then that's a waste of time. I should have done more with just eigen. I wrote more code. I'm starting to feel pressured myself though. I kind of have a deadline, you know. Getting old. Fun says, you're doing such hard work that I can't even understand what you're doing. Can you explain in a few words? In a few words, I'm writing a Vulkan engine. I don't know how many words you wanted. I have a to-do list. It's in the description of my current stream even. It says the to-do below. I don't know, I wrote it wrong. The to-do below this got interrupted by fix a push constant declaration when that has 2 or more members. That wasn't quite it, but anyway, I did that now, so I'm gonna just delete it. The to-do below that split texture into 2 clauses, one that is needed for the shaders to compile and one that represents an actual texture. Yeah, I gave that a lot of thought. And I think that maybe I should change it into that my texture represents a descriptor. So not the image, just the descriptor. Because this is my current application. We have two pipelines, left and right, and then we have an upper and a bottom, top and a bottom image. And we are currently using this as shader, I think. So my vertex data contains just this square, and then I have two instances, the top and the bottom. So this offset here, instance data, shifts it in the y direction, top and bottom. And I shift it horizontally left and right by using a push constant. And currently I'm switching between textures, top and bottom texture, by using the GL instance. But that won't compile because the fragment shader doesn't have access to it. So I did it slightly different. Instead, we convert the instance we have access to the instance in the vertex shader, and I just put it in an int, which you then pass on to the fragment shader as a flat int. I have no idea what flat means, and I'm going to look it up now. I did look it up before. Flat Vulkan or nah. GLSL flat int. Yeah, this is what I read before. Even voted it up. So you wanted to know what this flat means here. General case, there is no one-on-one mapping between a vertex and a fragment. No, of course not. By default, the associated data per vertex is interpolated across the primitive, aka triangle, to generate the corresponding associated data fragment, aka pixel. But, well, not really pixel, but the data needed to create the color of a given pixel from a given primitive. For example, you can have multiple triangles that overlap the same pixel, and then one could be hiding the other one, or one could be transparent and show a part of the other one. Then the fragments are the pieces of a single primitive, and the pixel is, of course, in the end, well, what you actually get in your frame buffer, the color. using the flat keyword, no interpolation is done. So every fragment generated during the rasterization of that particular primitive will get the same data. Since primitives are usually defined by more than one vertex, this means that the data from only one vertex is used in that case. This is called the provoking vertex in OpenGL. Also note that integer types are never interpolated. You must declare them as flat in any case. In your specific example, the code means that each primitive can only have one material, which is defined by the material ID of the provoking vertex for each primitive. Well, that's cool. Picture would be nice. Hey, here we have a picture. So here we have a primitive. It's a triangle in this case, and I think it's like always a triangle. And then you get triangles are in 3D space. You also have a viewpoint. Having the camera, the viewpoint, and the 3D triangle, you can do rasterization so that you know which part of the triangle overlaps with pixel in the screen or in the frame buffer. And apparently each of these fragments will get the same value. And that value then depends on the value of the, I forgot the word, what was it? Provoking. The provoking index. Now, I don't know which is the provoking index. Let's say this is the provoking index. Sorry, vertex. So this vertex has coordinates. It has a number, I think. It has a color. And it has an integer value. And this one has also a color, different coordinates, and also an integer. But if this is the provoking one, then all these fragments get the integer value that belongs to this vertex, while the color is an interpolation. So this, all three have a color, a floating point. And then when you're close to this one, you get this color. When you're close to this one, you get this color. And when you're somewhere in the middle, you get a mix of all three colors, depending on where you are. And of course, the same thing with the coordinates, like the UV coordinates, to look up the pixel in a texture. They get interpolated as well. And you pass the UV coordinate that belongs to this vertex, and that one, and that one. And then the interpolated UV coordinate, aka the place in the texture, that belongs to that fragment is calculated. Pass to the fragment shader for each fragment. But an integer, yeah, that would be a bit hard. If this has an integer of 1 and this has a value of 2, then what would you give this one? Or this one? It still has to be an integer. So an integer always has to be flat. Now we know what flat is. We still don't know what provoking is, but I think that provoking vertex is probably the one with the lowest index or whatever. However, depending on the order in which you feed it. So. And I think that most notably, normally that value is just the same for all three vertices, so it doesn't really matter which vertex is the provoking vertex, because the value is the same anyway. Which is the case in this case. The instance index is, well, instance, so you draw 6 cubes, and your vertex buffer consists of all the vertices of a single cube. Then the instance index is 0, 1, 2, 3, 4, or 5, depending on which cube you are drawing. but all your fragments belong to a single cube all the time. And therefore, every vertex of any given cube is just has the same value, the same index, instance index. And that, therefore, you can use that to switch textures as function of the instance, aka cube, whatever. But we can do more. We can even switch depending on, say, the face of the cube. 6 faces. Now we need another integer. And that integer we could get in the same way we get the UV coordinates. I'm looking for the UV coordinates here. I think that's this one. That one. That one. That one. That one. Yep. Took me a while, but my vertex data also has a 2-dimensional float vector, which are the UV coordinates inside the texture. That's a part of the texture that the triangle is overlapping, and you give it each vertex is, well, coordinates inside that texture. Now we can also add vertex data texture index. Here I use a push constant, but that would mean, yeah, that's kind of not how it is done normally. So imagine that this says vertex data. Then that is not available anymore in the fragment shader. But if every vertex would have the same value, there would not be a problem. We can just read it here and then write it to an texture index integer here, just like this one. And then declare it flat here on the input, read it again, and then use that. And then going to switch on that value, and then we just have we use it as an use it as an index into a texture array instead of using this branching here. But that means that every every provoking vertex of every primitive on a given face must have the correct index. And in this case, every vertex on the corner of our cubes belongs to 3 faces. Sorry, 3 faces. Yeah. So it's not as trivial then to get it right. Okay, I got distracted now. I was digressing. What is the word? What I wanted to do was so a given pipeline. Everyone knows what a pipeline is. Oops. Let's close this. I think this is from YouTube. A pipeline is something that you program or record in a command buffer, and then you can do a draw call, and then it executes a batch. That works by having vertexes, and then the vertexes are placed. Possibly tessellation happens. you have a geometry shader, then you get the rasterization, then you get the fragment shader, what you just talked about, and then eventually all the fragments are blended together into the frame buffer. So this is called a pipeline. And then specifically the fragment shader might read the texels from a texture at interpolated coordinates to get the color value at that point of the texture that you want to apply to that face, to that fragment. Now suppose we want to change that. So the pipeline uses a uniform sampler 2D. It's just a type. Circle and troop. So this is shader code, and we declare somewhere a uniform sampler 2D. In this case called the U texture top, and another one U texture bottom. And each of these things is part of a descriptor set. So actually it is a descriptor. It's described by a descriptor. You need a descriptor to access the actual texture. And the descriptor is put into a descriptor set. So this is which set it is, and this is which descriptor it is inside that descriptor set. So I would say no, I want to look at this one. Oh, it uses that, and that is a descriptor, okay? So a descriptor that was updated with a combined image sampler. But how does it exactly work? Well, if you look at the Windows code, draw frame. What we really do is we bind a pipeline. It's just a command buffer bind a pipeline. Okay, we're talking about this pipeline. Which pipeline? This pipeline that we just bound. Then we bind descriptor sets. So that goes one after another. So this pipeline now uses these descriptor sets. There is no talk about descriptors here, right? You just bind descriptor sets. That's it. Apart from that, you can bind the push constants and you can bind the vertex buffers. Push constants, vertex buffers are different, but the rest is descriptor sets. And a push constant, is just some value that you can push right in the middle of a command buffer and then read in the shader code. And the vertex buffers are only readable in the vertex shader, and they contain the vertex coordinates or data like UV coordinates, texture indexes, which we're going to use, but data per vertex and also data per instance. There's two types of them. but all the textures go through this descriptor sets thing. So I'm going to write this as the pipeline uses the descriptor sets. And then a single descriptor set uses descriptors. Contains descriptors. The bindings, binding 0, binding 1, and so on. And a single descriptor can be updated with a shader resource. For example, a combined image sampler, which means that it refers to two handles, an image handle and a sampler handle. You can view that as the actual texture data, but this is the actual texture data, and this is how to interpolate different pixels when your fragment is larger than the number of pixels that you have. I mean, even those do not need to line up exactly. They probably never line up exactly. Do I need to find a picture of that? It's not the clearest one. No, okay, maybe like this then. So like here, the blue things are the texels, or the pixels of a texture, and the larger black squares are your fragment. Then what is the color of this fragment? Well, the way that it is then calculated, it looks at the color of this pixel in the texture, and this one, and this one, and this one. I mean, that's what it could do. And then interpolate the color. So this is closer to that one than to that one, so this one weighs more heavy. So it's probably going to be a little bit more like that color than like that color. And those contribute about the same, I guess. So it's an interpolation in between these four colors here. And if the way that works would be the sampler. The sampler tells you how to interpolate from the texture pixels to the fragment pixel. Now the image handle is actually just a pointer to a buffer. So forget this, the sampler just hikes along here, so forget about that. The image is a pointer to a buffer on the GPU with the texture data. So So that's really specific. So the handle is specific, and that's like the cute kitten is the handle. But not necessarily the descriptor, because we could update the descriptor to contain a different image. Now we can have multiple images. We could have an image A, and we can have an image B. And then the descriptor could either be updated to correspond to the buffer A or buffer B, and then you see something else. Even though we use the same descriptor inside the same descriptor set inside the same pipeline. So how do we change the image with a given pipeline? It's not exactly how it is, of course. The pipeline is more like, let me shift this whole thing up. Shaders or modules. So the pipeline consists of multiple shaders, and each shader has one or more might read from, let me think, I don't think that's correct what I'm saying now. I think only the vertex shader sees it. Yeah. Descriptor sets are read by the vertex shader. If you want to use them by the fragment shader, you just have to, I'm not sure actually. No, it's not true. It's not true. Sorry. You can have descriptor sets available to the vertex shader, but also descriptor set available to even a certain binding. Just so if it's descriptor set comma binding, aka a descriptor, can be available to one or more of the stages of the pipeline. The vertex buffer can only be available to the vertex shader, but uniform buffers can be available to any shader, I think. And of course, the texture descriptors, the descriptors that point to a texture or to an image, etc., they can of course be available to the fragment shader. So it's specifically looking at the fragment shader only. We would have a descriptor set there and a binding number declaring a given descriptor. That then belongs to that shader, and the shader is kind of hard-coded in the pipeline, right? I mean, you cannot bind that separately. Pipeline is created using a certain compiled module. You would have to make a new pipeline if you want to change the shader. So that's why I did draw it like that. This is kind of a monolithic block. The descriptor set is what you bind to the pipeline. And the descriptor sets, of course, contain certain descriptors. Now you could change the descriptor set before or after you bind it. I mean, usually in the beginning it was just only possible you have to make a descriptor set, create it, and then you can bind it. And now you can also create a descriptor set and then bind it PMD, do I need to PMD outside? Yeah, I guess I have something. Yeah, you can even bind the descriptor set already to the pipeline and then update one of the descriptors. I think that is an extension, or you have to turn on a feature now. It's now in Vulkan core, so that is possible. But either way, I'm giving too much detail. I think that the point here was that if you want to change the picture of one of these things, you can either bind a different descriptor set, which then contains a different descriptor, or you can bind the same descriptor set, but change the descriptor set with a different descriptor. So you also change the descriptor. Or you can bind the same descriptor set and not change the descriptor set, so you just have a fixed descriptor, but update the descriptor with a different image. So there's basically 3 different ways. And now there is a 4th way, and the 4th way is the best, unfortunately. I have to drink a lot. Because the way I understood it, all of these things are pretty expensive. Re-updating it continuously is something you don't want to do. Well, you have to bind descriptor sets to a pipeline like every frame. But suppose this is the point where we want to change it, then the only possibility you have is change the texture from frame to frame. I mean, if you want to hijack the fact that you have to bind their descriptor sets anyway, you bind the descriptor sets and then you have a fixed texture. You cannot change that texture then until the next time you bind different descriptor set to a given pipeline. That's not what we want. We're talking not about having flashing textures that every frame show a different texture. I mean, that's good for movies. If you want to have a service in your scene that plays a movie, then you have to do that, I guess. Just bind a different descriptor set. But I'm more thinking about having a scene with multiple cubes, and each cube uses a different texture. And you definitely want to use a single pipeline for all the cubes. You do not want to use a different pipeline for each cube. I mean, it's just a cube. You don't want to have compile a new shader just to change your texture. That's bullshit. So we have one pipeline, and one pipeline is more than capable of drawing multiple cubes. Now it seems pretty logical, I think, that you provide a vertex buffer with the vertices of the cube, and then the instances, you have different instances, and then each instance is another cube. So then what you want is to change the texture as function of the instance integer. And that's not really possible in this way. I mean, where you're not going to bind a different descriptor set and using, I don't know, multiple pipelines of do a draw call for a single cube and then bind a new descriptor set and then use the same pipeline again with a different descriptor set bound. I mean, that's inefficient. If you enable the feature that you can bind, that you can update the descriptor after bind. You would not have to rebind the descriptor set. You can just change the descriptor, but that doesn't really work either because you still need to do synchronization correctly. So I don't think it's really an option that you just bind the descriptor set once and then put a new descriptor in it. I don't even see how you can do that. I mean, you would be part of the command buffer recording. So this is also definitely not the point where you want to switch textures between cubes that all are drawn in the same scene. On this point, it's equally impossible, if you ask me. So I think even I was talking about that when I was pointing here. It's really updating the descriptor. This putting a different descriptor inside a descriptor set, that's like not possible at all even. You have to just recreate a new descriptor set to do that. And then you have to bind it anyway. Rebind it. So no, all not really possible. So there comes the fourth method. The fourth method is not usable in OpenGL. At least you can kind of hack it, and then it's called bindless. But in Vulkan you can use a single descriptor to point to a whole array of textures. So now it points to an array. And then this becomes index 1 and index 0 and index 1 and so on. So then you have a shader bound to your pipeline, bound to descriptor set that exists of a descriptor that points to an array of images. And now you can easily switch between textures, namely by changing that index. And that index then could depend on the instance that you draw, and then you just, if you do it like that, you would have a cube, this image on all 6 sides, and the next cube as another image, and so on. Or you can put, you can make it even more elaborate and switch the index as function of the face. So not as trivial, but it's also possible. And then you can have a different image on each face of the cube, and multiple cubes, even again with different textures. Now, to use a different image on each face, that cannot depend on the instance that you're drawing. It must therefore depend on the vertex that you're drawing, or rather on an integer that is assigned to the, I forgot the word again, what was it called? Provoking index. So each face exists of a certain number of primitives, and then each primitive on a given face must have the same integer assigned to each of its provoking vertices. And then you can use that integer as an index into your array of textures, and then you get a texture, certain texture on that face of your cube or whatever. So I think that's the way to go. We definitely want and have to support arrays of textures. Otherwise, I wouldn't know how to do this. Then the C++ side. Currently I have texture, just a class. Hello, Post Bunny. What is it? Make sure to hide a Rickroll Easter egg into your code of the cube. I don't understand. So my texture class, when instantiated, gives objects that correspond to everything. And that was my mistake. It corresponds to a given descriptor set. So my texture corresponds to a set, say number 1, and a descriptor, say binding, I don't know, binding 2, and an image. Image handle X. And a sampler handle, of course. All in one. So there is no array inside, and there is also no way to use a different image, like a different cat, for the same instance of texture, which is absolutely horrific. I don't know how I designed it like that. Yeah. I don't know. I don't think there's much you can do about it. I'm not really per se against that my code is being used by humanity, even through an AI. It just feels a bit unfair that, you know, I don't get any dime of it. But I am not getting any dime anyway, so I don't know. I'm still sad about that. 2 weeks ago I didn't buy ASML stocks. I was planning to buy it on a Monday. I didn't. Then it started rising. Then I still did not buy it because it was like, yeah, I missed it. Now they are a few percent up, 5% up, 10% up. Damn it, I should have bought it when they were 5% up. Now they are 40% up. At 10%, I thought I should have bought it when they were 5% up. At 20% up, I thought, why didn't I just buy it at 10% up? Now they are 40% up, and I didn't buy them at all. If I had bought them at that Monday, I would have bought them at the very, very bottom. And probably it's going to go up 100% and maybe even 200% in the next 10 years. At least the next 5 years, maybe. I don't know. I have no freaking idea. I just don't feel... I mean, everyone is calculating in the future. Clearly, everyone now knows what is going on with ASML. And they calculate it in the future. So it's very well possible that they're hardly worth what the stocks are worth now. It's just gambling anyway. Stocks market is gambling. And it just sucks that when you are almost buying it, and then out of pure laziness you don't do it, and then you miss 40% going up in a few weeks. Same with Twitter, by the way. I mean, I believe in Elon Musk, and okay, I wasn't really on top of it by the day. It was just recently that I even learned that he really bought it, and I was like, well, probably I should invest in Twitter now. Elon Musk is the boss, you know. So I looked at Twitter, and yeah, since the moment it was really known for a fact that he took over Twitter, the stocks have risen 40%. And also, it's the same as with ASML. It's probably just a tip of the iceberg. He might 10x in a couple of years. And he might also not, because you can guess what he's going to do. He's probably going to combine Twitter with something like PayPal, but then digital money. Or he's going to make a WeChat where absolutely everything goes over say Twitter as an app. But most importantly, that people can just pay each other using the phone. You already had that vision in 1990 something. No banks, you know, the ultimate goal of all crypto, like Bitcoin, to shut out all the banks, just people paying people, no more inflation. Very, very, very nice towards humanity. He just wants the best for humanity, and you just know it. But, well, even though he's not doing it for the money, like he said, and I believe him, the stocks will go up like crazy if that is successful. But all the banks and all the governments will be against it. So am I going to put my money into Twitter? You just don't know. Because it will be literally like against the will of the governments if he succeeds. And he might succeed. In that case, you will make a crazy amount of money. But it's so fucking unlikely, you know. And people are already pricing it in. That's why it rose 40%. So if now you buy it, probably has 50% rise already. And then it turns out that his dream is shut down again with new laws and God knows all what. The government's all over him. They make it impossible. Then, I don't know. You might just lose money with it. But yeah, that's the stock market, right? You just don't know. If you were sure, then you would become really, really rich. But it's just gambling. By the way, I have only lost money with the stock market. I have only lost money. Every time I think, okay, this is going to happen, then it did happen. But the market reacted exactly opposite of what I thought. So I saw the inflation coming. Every time I see things coming, and it happens. And then I lose money because I thought that the stocks would go this way, and they go exactly the other way. Yeah. The bear market. There was something else, totally different. No politics, no money, no stock markets, no macroeconomics. Apparently some guy has solved something related to the Riemann hypothesis. I'm going to look at that. Riemann hypothesis. Is the Riemann hypothesis really solved? Skepticism. Not no. It said K-N-O-W, didn't it? Clicked on it. The Riemann hypothesis is a formula related to the distribution of prime numbers. Has remained unsolved for more than a century. Yeah, 160 years. I thought 150. A famous mathematician today claimed he has solved the Riemann hypothesis, a problem relating to the distribution of primes that has stood unsolved for nearly 160 years. In a 45-minute talk on 24th September, the Heidelberg blah blah blah, Michael Atiyah, a mathematician emeritus at the University of Edinburgh, presented what he describes as a simple proof that relies on a tool from a seemingly unrelated problem in physics, but many experts doubt its validity. Especially because Atiyah is 89, has been making mistakes in recent years. Ah, right. He's 89, yeah. I would almost hope he didn't solve it. Thought that guy published like one thing in his whole life. That was really interesting. So if the proof is right, you get $1 million. He did multiple things. Yeah. Yeah, his age is like really worrying me. You know, maybe he's just and it's a professor, mathematician, high IQ, and he's now 89. He might just be becoming crazy, if you know what I mean. It's really, 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 really unlikely. What? The Crickson proof depends on a quantity in physics called the fine structure constant. It's Describe the strength and nature of electromagnetic interactions between charged particles. By describing this constant using a relatively obscure relationship known as the Todo function, Atiyah claimed to be able to prove the Riemann hypothesis by contradiction. So he proved it wrong. Nah, no way that it is wrong. Everyone assumes that it is correct. It's probably nothing. And then on the same page, Alzheimer. How many more do we have? Pure coincidence. Pure coincidence. Well, this was from September 2018. Now, come on. I thought there was something more recent. It was the same guy, I think. Three days ago. Much better. That's the guy. Yeah, he was not a guy. Isn't it? Yeah. This is the article that I was looking for. Yeah, it's talking about me, but then for programming instead of mathematics. I just want to go on programming my in the rest of my life as well, I think. PDM. Sounds like the whole definition of random to me. So, okay, if you have absolutely no clue how primes are distributed, then they are distributed randomly, which means that if you divide by any prime and you look at the distribution of the remainders, every remainder will obviously occur in the same amount, right? Because they are random. So that doesn't tell anything at all, in my humble opinion. Totally true. Yeah, doesn't really say much, does it? Okay, I'm going to do something else, I think. Or should I continue with this? I'm pretty lazy. I started late today. I did all kinds of nonsensical things today. And I started late programming, and now I'm already fed up again. I think I should start way earlier. I don't know why I'm fed up. It shouldn't have been with coding. Right, okay, so the point is that I think one of the next steps is that I want to support arrays then. And then my texture is just going to be a descriptor. So I'm gonna rip out the image stuff, image handles. I mean, yeah. I don't know where it will end, but I have the feeling that that is probably a good idea to do. So that means I have to, let's say, remove the image and remove these two handles. And how can you do that? If I just delete them, I just get a billion compile errors. That's not really going to help. I think that a better way would be to first split this class up into a base class and a derived class, and then move the different things into one or the other, and then achieve the splitting like that. And now the updating of the descriptor with these handles happens last. I guess I should move these to the derived class. And in doing so, I would assure at least that all the code that is in the base class does not depend anymore on whatever is in the derived class, in which case I think I have done my splitting. And since this is one of them, I have to get rid of this as a base class and have to move that to the derived class. And therefore, yeah, how about my base class is going to look like this. And my derived class is going to look like this. or the other way around. Now let's give this a different name. I'm going to call it texture, but I'm going to put it in namespace descriptor, I think. But I want to keep it here for now. So currently I'm in namespace that. So let's just close the namespace. And then open a new namespace. Vulkan. Can type descriptor. So the base class is then the descriptor. I have to reopen it. This namespace. So my descriptor texture is then the texture that just describes the descriptor, and not the image or the sampler. And the base is defined in the same, of course. Serial builder. A shader resource. I did 4 declared texture. Oh no, like that. This has to be changed to a descriptor texture now. Yeah. Why not key base here? So now I made 2 classes, but this one is empty. That's not what I want, of course. So what is it that I can move up into this base class? And I guess this. Looks like it has only to do with the declaration stuff. Definitely. So I think that this is the first one that can go up. Well, not the first one. In fact, the base class was also moved already. Let's make it a class. Hello, Timothy. Private, public. Okay. This is assigned here. TLSLID full is appended here. String is texture. Looks like and needs to be also moved completely up to the base class. Should I do that now or shall I just stop the stream? I mean, shall I just stop the stream and do it, or shall I do it while I stream, or shall I do it after the stream? A member. Let me think. Prefix. Postfix. Do I no longer need a logical device? Guess not. Oh, I need to pass also everything I need to pass to the base class. Wait a minute. Which is nothing. Which is nothing. That's just a move constructor. Okay. Okay, yeah, still a move constructor. Because that is using a member as well. But I'm moving the right hand side already of the descriptor texture. Image is moved. Now the member is moved. And then the rest. And then there's just a missing empty line here. At least the comments belong to both. It's kind of confusing this way, I think. But right, let's do then just two things. The move constructor. Member. See, here's an interesting usage of standard move, by the way. I mean, this is the initializer list, move constructor, and we are moving the right hand side to the base class. What happens? Well, first we apply standard move. That is a texture, an R value reference texture. I mean, this is an R value reference, but immediately if you enter the function, it becomes a left hand, so an L value reference. So you have to cast it again with the standard move to call a base class constructor that again uses two ampersands. But if you don't really know what standard move does, you might think like, yeah, but I'm moving the right hand side here, which means that after that returns, there is no guarantee that I can use the right hand side object anymore at all, except destruct it. And that's the convention. But this executed first, and then when we return from this base class constructor, we move it again. What is that? And then we even take a member of it, and we move that. And another member, and we move that. So what is going on here? It's like totally ignoring that we already moved it. So yeah, I'm just saying, you really have to understand what this move does. And then all the magic is gone, and it's just totally fine. Totally fine. So what it does is it casts. Standard move doesn't do anything at all. It just casts the left hand, the L value reference to an R value reference, meaning that we're trying to pass that type to this constructor. Now this type is derived from that type. Therefore, if you try to pass it, that's perfectly okay. Because, this type is derived from that one. So you can just pass it and then you'll get a reference to the base class. An R value reference to the base class in this case. So it's just going to call this constructor with a reference equal to the whatever points to this base class. And now we do the same trick again. We cast it again to an R value reference, and then we pass it to base. So then the move constructor of base is being called. But that doesn't touch anything except base, of course, all the members of the base. The members of this aka a member is untouched. So afterwards we can just still access a member and move it as well. That is no problem whatsoever. So just cast it in order to call the right function. So this is completely correct, valid use of standard move. And it is not the case that if you use standard move on something, that suddenly you cannot touch it anymore or use it anymore. Now finally we need to do this one. As you can see, I do call the base class operator, and I said why not keep base? Well, because member is in the middle. So I'm going to add that and then do that there, and then call the base operator from there. So I need, yeah, just gonna add it first, paste it first there. And I'm lazy, so I'm gonna go back, copy this line. Oh, let's copy both lines. And go up again. Okay, like that. So now this one is called, which then first calls the base operator assignment operator, and then moves the member. Well, I don't know. RCT says that okay because C++ has non-destructive move semantics. Yeah. Basically, it's just a convention. And the convention is that if you call a function, I have a class A, and I call the function A, then I can still use A here, of course. And if I do standard move A, that only means that instead of calling void f a or f a const reference, they both exist. Of course, we don't know which one we call, but we could be calling either one. If a is large, let's delete this one. So instead of calling that, we would be calling now this function. It's just another function because it has a different argument. So we can use overloading by using different types as argument. So we call a completely different function. That's it. And then what is this function doing? What is it allowed to do? It's allowed to do, by convention, stuffs that afterwards leaves A in a state that you should not use it anymore. You should only destruct it. So after this F, by a convention stuff, then here you should not use A anymore. And then of course this is a part of a scope. So at the end of the scope, A is destructed, but that's okay. But if you leave this empty, you just add hello. Sorry, but then it's doing nothing to A, nothing at all. So if you know that you don't do anything to A, it's perfectly okay to use A. Use A here. I mean, this function do nothing. If you well print something, but that's it. A is not being touched at all. You just cast it. You call this function, and it's not doing anything with A. You can just use it. And what I did is that A is derived from B. Let's say we have a struct A, which is derived from struct B. And then my function is actually taking a B, which is perfectly fine. If you cast to R value of A and then pass it to a B, that's fine because, well, it's a base class of A. And then by convention, you should, after returning from here, you should no longer use the B, which is the base class. So if this thing, well, let's use a string. If A defines an S and B does whatever it does by the convention, then it's still okay to use the S because B, the move whatever of B is not touching the S. This is a member of A. So then afterwards, it's still okay to use AS here, but it would not be okay to use anything from B, from the base class. Well, I hope that's clear enough. And then it was 11 p.m. here. I'm going to put the plastic outside and then do something else and then go to bed. So good night, everyone. Thank you for keeping me company. Hopefully I'll see you tomorrow. My throat is hurting. Talk too much, I think. More water. You always have to drink lots of water before putting plastic outside. Yeah, okay. Good night, everyone.